So we're looking at y equals e to the negative 2x in between 0 and 1, rotated about the x-axis. So this is going to be our decreasing exponential function. Let's say that 1's right there, 0, and it is above the x-axis. So there's the region. The biggest thing in doing a volume for a region of a volume of revolution, is identifying your radius. Well, since our axis of rotation is the x-axis, here's our radius right here. It's just from the x-axis up to our curve. Therefore, the volume is going to be from 0 to 1, y squared dx. Pi, I forgot the pi because we are rotating it. So I'm going to plug in what y is equal to. So pi, 0 to 1, e to the negative 2x squared dx. That's it. We'll simplify and solve this integral. We get pi, 0 to 1, e to the minus 4x dx. Doing the antiderivative, we get pi, e still to the negative 4x, and it's going to be all over a negative 4 from 0 to 1. Now this time we cannot just ignore the 0. You're going to see why here shortly. So we have pi e to the negative 4 when we plug 1 in over negative 4 minus, now when we plug 0 in we get e to the 0, which is 1, so 1 over negative 4. And e to the negative 4th over negative 4 is much smaller than this. So the negative and the negative are going to make that positive, so one way we might write the answer is pi times 1/4 minus e to the negative 4 over 4. Or we could pull out the 4th and put it underneath the pi, so pi over 4 times 1 minus e to the negative 4th. And then that could be calculated if we need a decimal answer. We weren't given units on this, but if we were, it would be cubic units for our answer because we're looking at a volume.